Hey, all dear students, in the series of lectures on kinematical graph, so far we have covered the theory related to kinematical graphs. Now we'll take some problems. So in this video, we'll take a JEE main level problem. Some of the problems have already come in the previous year. So let's start. So let's see this question. This question, all the graph below are intended to represent same motion. One of them does it incorrectly. Pick up, pit it. Basically, which of them is not representing the same motion? So let's start with the option A. Here, this is a velocity and position graph. So see, choose one position and you can see that for the same position, we can have a two velocity, one positive velocity, one negative velocity. And if we go this way, so we start from a positive velocity. Velocity decreases, velocity is positive and decreasing magnitude, becomes zero at some position, and then velocity becomes negative. So this kind of motion could be when we throw a body vertically upwards. It goes under gravity, so it goes up and reaches to a maximum height and then comes back and reaches to the initial position. And all during this motion, the acceleration is constant. And if we take a positive direction upward, so the acceleration will be A is equal to minus G. And here at every position, say at some height, when the body goes up, the velocity is positive, and when body goes down, velocity is negative. That is represented by two velocities at the same position, one positive, one negative. There is a maximum height at which velocity is zero, that is represented by this point. It is started with the zero position here and reaches to the zero position. So that is that type of motion. And if I say that this is a motion under gravity without any air resistance, so acceleration is constant, and that acceleration is minus G. So in the velocity time graph, what happens in the velocity time graph? If the acceleration is constant and negative, so it will be a straight line with negative slope, and that is very well represented by this graph. And also you can see there is a turning here, and when VT graph and there is a turning, so in the VT graph that will intersect time axis, that is also represented by this. Up to here, before this point, velocity is positive like all these points, and after this velocity is negative all these points. So both are A and D are the same motion. And if acceleration is a constant, VT graph will be a straight line and position time graph would be a parabolic. And the slope of a position time graph gives the velocity. And you can see that in between at the mid of the motion, here the velocity is zero, and that zero velocity is represented here because here the slope is zero. And you can see that here it goes with a positive slope. So this slope is positive in initial positive velocity, then the magnitude of slope decreases, here it becomes zero, then the slope negative, slope mean velocity. So it goes up with a positive velocity, magnitude of velocity decreases, becomes zero, and then magnitude increases, and slope is negative, mean it goes in the negative direction. So A, C, D are the same motion. In the B, it is a distance graph. Even if it was a displacement graph, you can see there are distinct three regions of the graph. In this region, this is a concave up, some curved. If the distance graph is curved, so displacement graph will also be curved. So it has a acceleration. And if the distance graph is a straight line, so displacement time graph would also be a straight line, and that would mean a constant velocity. And in no part of the motion bodies moves with a constant velocity. So option B tells a different picture. So ACD represent the graph for the same motion and BCD represent for a graph for different motion. But we had to choose the graph which is incorrect, so we will choose option B. Let's see this question. This question has been asked in JEE. So here is a acceleration time graph, and particle starts from rest. We have to find the maximum speed of the particle. So it's very clear that the area of the AT graph is the change in velocity. So you can see that for the whole time interval, this area is how much? 11 into 10 by 2. So that is how much? 55 meter per second. And this is a change in velocity. So this area is change in velocity. So v minus initial velocity is 55. So v is equal to initial velocity is 0. So v is equal to 55. And as we go, so far area is positive, mean the velocity is increasing. So more positive area, more velocity increases. More positive area, velocity increases. So velocity is continuously increasing till 11 second. And so it means the maximum speed would be at t is equal to 11 seconds. So B is the correct answer here. The next question, this is a velocity versus time graph for the motion of a particle shown in the figure. Which of the following statement is correct? So let's see options one by one. Option A says between 0 to 3, mean including this time interval, including the moment 0 and 3, mean up from here to here. So V average is less than. So if I just draw a line like this, if VT graph would be a straight line. The average velocity is the initial velocity plus final velocity. So the graph had been like this that I have drawn. So in that case, the average velocity would be 0.5 because this velocity here is a 1 and the velocity here is 0. So average of these two is 0.5. So because this part is below this line, so average velocity from here to here is less than 0.5. So option A is correct. And then from 3 to 5, this 3 to 5, you can see here, this 3 to 5, the average velocity, they are saying 0.75. And if you see that here, if I draw a straight line like this from here to here, area under VT graph gives me the displacement. So suppose if the VT graph would be the one that I have drawn here, if this was the VT graph, then the average velocity would be the V initial here and V final here divided by 2. So here V is 1, here is 0.5. If the VT graph would be like this, then the average velocity would be 1 plus 0.5 by 2 means 0.75. And see carefully. If I see the area under this graph, and that is the displacement from 0, 3 to 5. And you see this graph. Here what happened? This is the area missing and that area is covered because you can see this area and this area the same. So area under this graph from 3 to 5 is same as area under this graph from 3 to 5. So we can see that the displacement from 3 to 5 is same if we take this graph, and using this graph, the average velocity is 0.75 meter per second. So this is also a correct option. Now let's see option C. We can immediately disregard this option because it is saying that between 0 to 5 second average velocity is more than 0.6. More than 0.6 minute can be very large number also. But since the upper limit of the velocity is 1, so the average velocity would be obviously less than 1. And they are saying it is greater than 0.6. Greater than 0.6 could be so many numbers greater than 0.6. So that is not possible. If it was written less than 0.6, I would have explored. Now the acceleration is minimum at t is equal to 4. So acceleration would be minimum where the slope is least. And I can see that the slope of VT graph here is minimum here. And then the slope is increasing. And here the slope is like this. And this slope This is a negative slope. But when we say acceleration is minimum, what we mean in the magnitude of the slope. So even less than this slope is in magnitude here. So this option is also not correct. So correct options are A and B. So let's see this question here. The velocity time graph of a car and its scooter is shown in the figure. There's a graph for the scooter. This is graph for the car. The difference between the distance traveled with the car and the scooter in the 15 second we have to find. And the time at which the car will catch up with the scooter. So we have to find two things. In VT graph, the area is the displacement. So if we till 15 second, if you want to find the displacement of the car, that is this area. So this is displacement of car, say SC. So this area is equal to how much? 45 into 15 by 2. Let it be like that. And displacement of scooter is this area. So that is 30 into 15. So displacement of a scooter is 30 into 15. So their difference is equal to SS minus SC. So 30 into 15 minus 45 into 15 by 2. So take 15 common. 30 minus 45 by 2 is 22.5. So that is a 30 into 15 into 7.5. And that will be how much? 112.5 meter. So it could be option A or C. And then at what time the car will catch up with the scooter? So when they started from the same position. So when the displacement covered by them would be equal, they will catch. So you can see that till 15 second, they have not catched up because there is a difference between them is 112.5. And here the scooter is ahead of the car. So after 15 second, they will catch. Suppose they catch, say, some after, say, time t time after 15 second, t time more after. So here, so till that time, if I draw here, this is the position here. So suppose they catch here at 15 plus t time. So by that time, the displacement of the car would be this area, and displacement of the scooter would be from here to here. So when they catch up, the displacement of a scooter is equal to displacement of car. Displacement of a scooter is moving with a constant velocity 30. So its displacement would be 30 into 15 plus t. And displacement of scooter so far here, up to 15, this is the displacement of the scooter. So how much that is? 45 into 15 by 2. And another time t. After 15 seconds, speed of the car has become constant, that is 45. So 45 into t, that is more. So what we can do, like divide by 15. So that will be 3. That will be 3. That will be cut. I'm cutting by 15, and that will be 2. So simplifying it, that will be 30 plus 2t is equal to 22.5 plus 3t. So we will have t is equal to 7.5. So this is 7.5 after 15 seconds. So our answer will be 15 plus 7.5. So that will be how much? 22.5 seconds. So that is this option, A. And next question. Here a displacement time graph of a particle is shown. The figure shows. We have to see each option one by one. So option A is saying the particle starts with a certain velocity, but the motion is retarded and finally the particle stops. So position time graph, slope gives the velocity. So here if I see, make a tangent, and this is a positive slope. So the particle starts with a u greater than 0. And as particle goes, as time passes, you can see this is a less slope than this. I mean, the speed decreases, speed decreases, speed decreases. Now it is asymptotically becoming 0. So we can say that the particles start with a positive velocity, speed continuously decreasing. It means the motion is retarded, and uh, finally the particle will come to a halt. So option is correct. If option is correct, so option B cannot be correct because particle is retarded, speed is continuously decreasing. The acceleration of the particle is constant throughout. The acceleration of the particle is constant throughout, that you can see from here. The final, if you see that, finally, when you see this part, here the velocity is becoming 0. And finally, when it comes to a stop, I mean the velocity and acceleration both become 0. But initially there was some acceleration. So acceleration is not constant. Acceleration is there. Actually, that is a retardation, but that is a not constant. Now, last option. The particle starts with a constant velocity. Then motion is accelerated, and finally the particle moves with another constant velocity. This is wrong. It is wrong to say particle start with a constant velocity. Particle start with velocity, and immediately after the motion was retarded, and it was continuously retarded, speed was continuously decreasing, and finally it comes to a halt. So this option is also incorrect. So only correct option is option A. So thank you for watching this video. Stay tuned. We'll bring with more questions, and that time, next time, it will be a bit higher level of questions. Thank you.